Hello guys, so today we are here to solve the today's challenge of K Radius Subarray Averages. In this problem, we are given a zero-indexed array nums of an integer k, okay? And the K radius average, so we need to find the K radius average for a subarray of nums. Okay, so what does it mean? K radius means, let's say k is 3 and we are at 9, then we have to find all the three elements on the left and all the three elements on the right. Okay, so sum of all these numbers 7, 4, 3, 9, 1, 8, 5. When we are at 1, then we have to find the average of all three elements on the left, 4, 3, 9, and all three elements on the right, 8, 5, 2. So this is what, this is representing the radius. And if we are at 8, then we have to add all the elements, 3, 9, 1, 8, 5, 2, 6. So average of all these elements. So this is the problem. Okay. And see, obviously, when you are at 2, then there are, when you are at 5 or, any other such position, let's say 5, then there are no three numbers on the left. So if there are no three elements on the left, then we are putting for 5, we are putting -1. So wherever the elements are not there, we are putting -1. For those positions where elements are there, we are putting uh, the actual average value. Okay, so with this, I hope this problem is clear. Okay, so you can see this for yourself. So for 7, the first index, there are, zero elements. So for this, since there are no elements, it doesn't satisfy the K radius criteria, so I'm putting -1. So for 4, it has only one element, so we are putting -1. So for 3, we have only two elements, so we are putting -1. So this is the thing that we have to understand here. So unless and until there are given particular number of elements on the left and the right, if they are not there, then we are putting that value. Otherwise, we are putting -1. Okay, so with this, let's try to solve this problem. So to solve this problem, we have to have int array result is equal to new int array nums dot length. Okay, if we have to put one check, if nums dot length is less than so since we are taking for this and for any index, we are taking k elements on the left and k elements on the right. So there are k elements on the left plus k elements on the right plus k is 2k plus 1, the index itself. So if it is less than the nums of length is less than this, then we are taking 2 times k plus 1. Okay, then if it is like this, then what we are doing that we are returning arrays dot fill result with -1, and then we are returning result. Okay, okay. We can do this thing, on top itself. Let's not do that. Okay, then we will come again. Okay, now we have to. Okay, so for all the elements which are within that 0 to uh, k less than k, so we have to fill -1. So we have to do it like this. For int I is equal to 0, I less than k plus plus I plus plus I plus plus I. We have to fill result of I is equal to -1. And then on the end, for int I is equal to nums dot length -1, I less than nums dot length minus k. is equal to I should be greater than. I should be greater than, and then this is minus I. Then for this again we are putting a result of I is equal to -1. Okay, okay, and then for and I is equal to we have to first declare some values. So long of sum is equal to 0L. This is the initial value. Okay, and then uh, int divisor is equal to 2 times k plus 1. Okay, and then for int uh, I is equal to 0, I less than uh, I less than 2 times k k plus 1, correct? So here 3 plus 3 6 so less than 2 times 6 plus 1 7. Okay, fine, this is fine. Okay, then we are doing plus I. Okay, like this, and then we are going to add, sum is equal to result of I. Sum plus is equal to result of I. Sum plus is equal to I. Okay, and then result of k is equal to end of sum by divisor. Okay, like this, and then we'll have to do one more logic here. And I is equal to k plus 1. I I less than I um, less than nums dot length minus k. Nums dot length minus k. Okay, I less than equal to k plus I. Okay, so for this we have to do sum is equal to sum minus just you can write it like this, minus nums of nums of nums of nums of k minus 1. So nums of we have to have k minus, so we are at this kth index 3 minus k3 minus I minus k. So k plus 1, we are at this index I minus k will be I minus k. This will be 4 minus k3, 1 minus 1. Okay. Yeah, like this. Okay, and sum plus is equal to k nums of I plus k. Okay, and then result of K is equal to the result of I. Result of I is equal to, we have to do this and then we have to cast it back to end. And then at the end, we have to do the term result like this. So let's run this. So it's saying that there is index 9 out of bounds for length. Okay, so there is some mistake here. Okay, so now start length minus 1. Okay, so this is the input that we are getting. Now the problem is in this part. Okay. Okay, so why this is not coming sum equal to I less than 3 5. Oh, we have to add nums of I. Okay, and so let's run this. So it's running fine. Now we'll do submit. So this one is failing. Yeah, 4,000. Okay. So what is the problem in this? Let's do this by divisor. Okay. So we have to cast the division, the result of the division, not just the sum. Perfect. So this is the way to solve this problem. If you have any doubt, please post it in the comments. One thing that I would again like to stress, that we are casting the result of this division. We are casting the result of this division. We are not casting the if we are doing it like this, then what does it mean? That we are casting this sum value, but we don't want to cast the sum value, just we want to cast the whole sum by divisor. That's why we are doing it like this. So with this, I think we are in the clear, and I would like to stop this video. If you have any doubt, please post it in the comments and I'll happily answer those doubts. Thanks a lot.